Triple integrals and average value. We do a triple integral to integrate over a solid region. We'll see some examples where we have to do this. We're going to start with the average value. The average value of a function is going to be the function integrated over this solid region. This capital omega is just a way of generally indicating a solid region rather than an area or a surface. We integrate the function. dv is a generic way of saying a small element of volume. That could be dz, dy, dx, be a small little cube. And then over integration dv over omega, that's just a fancy way of saying the volume. If we have a cube, as we have in this case, you can just figure out the volume, length times width times height, instead of doing the integration. We're looking at this example. F of xy equals 2x on this Cartesian product. That's a unit cube. And we're identifying this region R in the xy plane as this, x between 0 and 1, y between 0 and 1. I'll explain why in a minute. It's very easy to see what the average value is. This function only varies with x. Here it would be 0, here it would be 2. The average value would be 1. Halfway between 0 and 2 is 1. We expect 1 for an answer. The best way to think of a triple integral is to first of all set up an xy double integral. This is going to be over region R. And then inside, these are going to be z limits. We want to integrate the function 2x, and the order of choice is usually dz, dy, dx. And so z is right here, and then dy, dx. The way we think of a triple integral is start with a double integral. What limits do we have to integrate over this rectangular region? Well, we can integrate from 0 to 1. Integrate 0 to 1. X goes 0 to 1, y goes 0 to 1 for each x. And then we have to ask at this point, we want to go from lower to upper. This is the lower surface, and that's the upper surface. Now with a cube, these limits are going to be constant. Z always starts at 1, z always starts at 0, z always ends at 1. So z goes from 0 to 1. Now we have 2x dz dy dx. Now we can go about evaluating this integral. We can start here. Okay, 2x is constant, so we're going to integrate dz and get z. So we have 0 to 1, 0 to 1, 2xz from 0 to 1, dy dx. Substitute for z, and we get integral 0 to 1, integral 0 to 1, 2x. You can put in 1 minus 0, which is just 1, dy dx. And of course, 2x dy gives us integral 0 to 1, 2xy from 0 to 1 dx. And we can substitute 1 and we get integral 0 to 1, 2x dx, which is x squared from 0 to 1, which ends up just being 1. So that's the numerator. Okay, this denominator, this volume integral, there's no need to even set up the limits. This is just simply 1 times 1 times 1, which is 1. And so F average is simply 1 over 1, or 1, as we expected. we figured the function was 0 here, 0 in the back face, 2 in the front face, 1 in between. And it only varied with x. It didn't vary up and down or back and forth. So as expected, fairly straightforward process. We'll be back with another short video calculating center of mass for a simple integral like this.